Today's lesson is Unit 5, Day 4, Gerrymandering. Our objective is that you'll be able to define gerrymandering and use our Polls-v-Pauper ratio as a metric to the extent to which a congressional district is gerrymandered. So, in order to understand gerrymandering, there's a couple of U.S. government things that we need to understand. First, our United States government is broken up into three branches: our legislative, executive, and judicial. As we are talking about gerrymandering, we're in particular looking at our legislative branch, which is also split into Senate and House of Representatives. Now, every single state can elect 2 senators to represent the state at the Senate level. And then depending on the population of each of the states, they can elect a certain number of House representatives who can also then vote for different laws and represent the state at a congressional level as well. In order to determine how many state representatives each state gets, every 10 years we hold a census. So the census is an attempt to count how many people live, and it does not have to be a citizen of, but they just have to live in a state. The last time we had a census was in 2020. And because of the growth of the population in the state of Texas, we went from 36 to 38 representatives. So based on new data, every 10 years, states will draw new maps of congressional districts so that each district can elect one representative to go to Washington, D.C. and represent that section of the state. What you'll see is on the right, we have a map of the United States and how many representatives different states have. You'll see that California has a lot, Texas has a lot, Florida has quite a few. And then New York also has quite a few. And then there's some states where the populations are just much lower, and so they have fewer representatives. Gerrymandering is when the congressional district is created with the intent of favoring one political party over the other. So since Texas has 38 representatives, the Texas state government can decide how they want to break up the state of Texas so that we have 38 districts. And then the people inside of each district will then go ahead and vote for one of their representatives. Whoever political party has control of the state government then can make congressional districts that favor their party, so there are more Republicans or Democrats elected to our state government, to Washington, D.C. as a state representative. One way that we can measure the extent to which a district is gerrymandered is by using something called Polls-v-Pauper ratio. So what I want to show real quick on the right is this is the congressional district map for District 33 in Texas. This is about where our school is. So if you live close to the school, there is a chance that you're in the 33rd district or in the 6th district. Before 2020, the first was what our district looked like. And what you can see is it follows this section here is a lot of Highway 30, and then this section being Dallas, and this section being Fort Worth. All right, so it's a pretty large span, but what you can see is that a lot of the space directly close to the downtown of major cities, they've condensed into one district, and they did that strategically. And then what they did in the new map is made the perimeter of this district even more of a crazy shape. Okay, so that outline there is District 33 currently. So what I want to show is how we can use the Polls-v-Pauper ratio in much simpler districts so that you can apply this to the congressional district that you will be assigned later for our project. So what we need to do first is compute the perimeter of this district. All right, So if we know that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 on this side, and then 1 here, 11 here, and 1 here, the perimeter is just going to be 11 plus 1 plus 11 plus 1, which is going to be 12 plus 12 is 24. Second, we need to find the area of the district, right? So this one is just a rectangle, so we can multiply base times height. But if we have composite figures, then we'll have to break up the more complex figures into smaller ones that we do know how to find the area of. But area for a rectangle is just base times height, which means it's going to be 11 times 1, and the area is going to be 11 units squared. Now, we need to find out what the radius of the circle would be if it had the same circumference as the perimeter of the district. So what we're going to do is take the perimeter and set that equal to our circumference equation and solve for radius. So we want the circumference to be 24, and we know 2 pi r is our equation for circumference. So what we can do is divide both sides by 2 pi and solve for the radius. Let's see. And then give me just a second so we can calculate that. 24 divided by 2 and pi, we get about 3.8. Okay, so with a circle, we now have a radius that is going to be 3.8. We want to find out what is the area of that circle using pi r squared. So here's pi, our radius is now the 3.8 squared. And we get 45.6. Last, what we're going to do is divide the area of our original figure by the area of the circle. So we're going to do area of our district divide by the area of our circle, and that's going to be 11 divided by 45.6. 11 divided by 45.6. We get 0.24. So our answer is 0.24 is our Poulsby-Popper ratio. The way we understand this number is that numbers that are closer to 0 are very gerrymandered. Numbers that are close to 0.5, somewhat gerrymandered. And then numbers that are closer to 1 is not very gerrymandered. And since this value, 0.24, falls between 0 and 0.5, we can say that this district is relatively gerrymandered. Which again makes sense because it's a pretty skinny district, and we're looking at how close is our original district to being a full circle. And it's not very close to being a circle. Right? So take some time and try student example number 1. Okay. Teacher example number 2, we're going to follow the exact same steps, but now we have a slightly more complex looking district. But our first step is we need to find the perimeter. This line right here and here tells us that those values are the same, they're congruent. And then that gives us every single side that we need in order to find the perimeter. So if I decide I'm going to start counting at this 7, then I'm going to do 7 plus 6 plus 5 plus 10 plus 15 plus 5. And I can double check. 1, 2, 3, 4, 5, 6. Good. So here, this is going to add up to 20. And then this is going to be 15. And 12 is 13. So if I add those together, 28 plus 20 will give me 48 inches. Second, we want to find the area of this district. So we can cut it up a couple of different ways, but I think I want to use this rectangle here, this rectangle here, and then this triangle here. So I'm going to number them 1 and 2 and 3. Okay, so in order to do that, I need to fill in a couple of different numbers. My first shape here, I have a triangle. If I know the entire bottom is 15, I know that this section is 5, this section is 7, that adds up to 12. 12 minus 15 leaves me with this section being 3. All right, second, I know the entire right-hand length is 10, but a section of that is 6. So this leaves me with this height of 4 here and this height of 4 here. Now I have all the information that I need in order to find the area of my shapes 1, 2, and 3. So shape number 1 is a triangle, 1/2 base times height, 1/2 3 times 4, 12 times 1/2 is 6. Number 2 is a rectangle, which will just be base times height, and it's going to be 7 times 4, which will be 28. And then my third one, again, base times height, is going to be 5 times 10, which will get me 50. From which point I'm going to add up all of my values. 50 plus 28 plus 6, I get 84. My next step, I'm going to take my perimeter and set it equal to my circumference equation. So 48 equals 2 pi r. In order to solve for the radius, I'm going to divide both sides by 2 pi. So I'm going to do 48 divide by 2 and pi. I get about 7.6. So I can imagine having a circle here where my radius is 7.6. In order to find the area of the circle, is going to be pi r squared. And I get 182.4. Inches squared. So now that I have the area of my original district and the area of my circle, I can divide the area of the district over the area of the circle. 84 divided by 182.4. And I get 0.46. So again, my poles v popper ratio is 0.46, which on the scale of 0 to 1 is about in the middle. So I would say that it is somewhat gerrymandered. Okay. Go ahead and try these independent practice questions on your own, and then write a quick reflection, please. Okay. Thank you.